Okay, so thank you everyone for joining. I am Gaurav Kukreja. I am a software engineer at Yugabyte DB, and I've been working on the cost-based optimizer. And I'm here to talk on this tool that we've developed called CBO Stat Dump, which is useful for reproducing complex query planner issues that occur on customer production environments. So we had a training on Wednesday, and we spoke a lot about CBO, and I want to re-emphasize, so CBO is a very complex topic, and debugging CBO issues is even more complex. As you can imagine, and I'll go into more details on that later, but CBO has to pick from a wide range of possible execution plans, and it has to choose from that an optimal plan to run this query. And there is a lot of assumptions that go into this, and so it's not always an exact science to find the best query plan. And then when you have a complex query, so there's a exponentially large number of execution plans possible for that query. And so once you have a plan, you can't even very easily tell whether this is indeed the best plan or not. So testing a CBO itself is a big challenge. And so even before we started working on the CBO, we invested a lot of effort in developing a set of tools that would help us test the CBO and also help debug issues that we encounter. And so I'm going to talk about one of those tools, CBO Stat Dump here. And I'm also going to briefly touch upon this other tool because there is a lot of synergy between these tools. So just a quick recap. SQL, is a declarative language. It doesn't tell you, so the developer doesn't tell how a data needs to be computed. It just tells how the data should look, right? And it's then the job of the CBO to then pick a most optimal execution plan from all the possible plans, right? And so what could that be? So you could, for each table, you could have different indexes, different scan methods to scan that table. You could have a different join methods. You could have different join orders. I have here a simple example for a query that is trying to fetch all books from the science fiction genre and also the names of the authors and publishers with that. And you can see that even for this small query, there can be a large number of execution plans that are possible for this query. I just want to give more perspective on how well does the CBO perform. We have this tool called Taco that I just mentioned before. This is a tool which we implemented to test the accuracy of a query optimizer, and it's derived from a paper with that same name. And what we found, we tested Postgres 15, and we tested it with the join order benchmark. This is a benchmark that comes from another popular paper, and it's a data set derived from IMDb. And what we found was that Postgres 15 was only able to get the best plans for roughly 30% of the queries, or 33 queries out of the 113 that are part of this benchmark. And this tool, how it works is it runs this query and it gets the default plan, and then it runs the same query by applying hints and forcing different execution plans for the same query. So it's trying to find if it can find a better plan than the default plan itself. And so that's how it found that Postgres was only getting the best plan for 33 queries, and you could achieve a lot of speed up if Postgres was getting the best plans. In some cases, the speed up can go up to 16x, as you can see on that histogram. So this is to say that this is a big problem. And one more thing I want to emphasize here is that over the last 7 years, so I've been testing from Postgres 11 to Postgres to the master right now, and what we found is that these numbers have not changed over so many years. So that also tells us actually CBO is a very hard area to work on, because every time you try to fix something in CBO, something else might break. And so developers are very hesitant to try something new or try something aggressive there. And that's also because testing it is so hard. I'll just quickly go over how CBO works. So as I said, there can be exponentially large number of execution plans to search from for a simple query. And so searching this vast search space is very difficult, so it uses a dynamic programming approach. On the left, I have this image that depicts how this works. So you have a join with 4 tables. And so what it does is it breaks down this query into subqueries, and then it tries to find the best plan for each subquery. And then iteratively, it will combine these plans to find the best plan. That's the dynamic programming approach. So now to compute the cost of a sub-plan, it needs, the cost is basically an indicator of how much execution time this sub-plan will take, right? And to compute that, a lot of it depends on how many rows are input to that sub-plan and how many rows come out from that sub-plan, right? And so that is done by the selectivity estimation. And so for selectivity estimation, the CBO uses some statistics that are collected from the data. So we basically create a random sample from the data set, and then we compute some statistics on that data. And using those, the query planner tries to estimate what would be the selectivity of a particular query. And then this information gets fed into the cost model, which emulates the execution pipeline, and it estimates the cost of executing this operation and generating the output. So basically, if you see here, the query planner depends on a few things to find the best plan. And most importantly, it's the statistics and some configuration parameters and the DDL. So the idea is that if we were able to reproduce all of these conditions in a test cluster, then we might be able to force a query planner to make the same decisions that it was making on a production environment in the test cluster. So we don't really need that data. And that can help a lot. So let's look at all the things that the query planner looks at. So it looks at rel tuples and rel pages from the PG class table. It also looks at PG statistic, which contains the column level statistics. It can look at PG statistics ext, that's the extended statistics, that is statistics on combinations of columns in a table. And the data is split into the ext and the next table, the ext data table. It could also depend on GUC parameters like work mem, max parallel workers. And then, of course, to reproduce that, you would also need DDL. So you need the DDL for the tables, the views, indexes that might be used there, extended statistics, and UDFs. So that's what this tool is supposed to do. It's supposed to extract all of this information and import it into a test cluster, which doesn't even need to have the same scale as the production environment, and it should still achieve the same query plan. Now, there are some caveats here. So we started, so as you know, Yugabyte DB was based on PG11 earlier, and there these things were working much better. So, but there were some enhancements to PG15, which made it such that it doesn't work seamlessly out of the box. So one of the problems is, so PG added an optimization to mitigate this issue with stale statistics. So these statistics are collected periodically, and so it can get stale after some time when you're adding data to the table. And so what PG15 does is it looks at, to compute the actual the current number of rows in a table, it extrapolates the number of rel tuples that is in the statistics by dividing it by the actual pages in the table, so that it can find from the file system, and then dividing by what rel pages we had recorded last time. So it extrapolates the number of rel tuples. Now what happens is on the test cluster, because the tables are actually empty, this actual pages will be 0, and so the test cluster Postgres will say, hey, there's 0 rows in the table. Now obviously that's not what we want, so we need a patch, but this patch is only needed on the test side, so there's no changes needed on the customer deployment side for this to work. But the only problem is if the statistics are actually stale on the customer's side, he'll see some other rel tuples and your test cluster will see another rel tuple. So so if the statistics are stale, this plan may not reproduce accurately. The other caveat is this system catalog table, the PG statistic ext data, which is used to store extended statistics, uses some pseudotypes, and Postgres doesn't support inserting to this table because of these special types that they are used. And so this is another patch that is needed, again, on the test side, not on the production side, to allow inserting to these tables. And so this is how the tool can be used. So this is mostly self-explanatory, but I'll just go over it. So you have to specify, so this tool is a Python script. You can connect to a database instance. You specify the host port and the credentials. You have to provide it a database. You can provide only a set of schemas. So then in that case, it only exports DDLs and statistics only for all the objects in that schema. And you can also specify a particular query. So you can give it a query which has a problem, which is producing the wrong plan. And in that case, it will only try to dump the statistics and the DDL only for all the objects that are used in that query. You can also specify an output directory. And if you're using it with Yugabyte, you might need to add a YB mode, which changes the default values and also exports some additional things that we need in Yugabyte. And this is what the tool then produces. So it's like a support package. It contains all the information that you would need to reproduce this issue. So it starts with version. So what is the version that the customer is using? It also exports the GUCs that the customer might have overridden. Okay, this is not working. So you can, if the customer has overridden some GUCs from the default values, then it will also output that. In Yugabyte, we have G flags, so it will also export those G flags. It will export the DDL for all the objects that are used in that query. If you specify a query, or it will export all the DDLs in that namespace, in the namespaces that you specify. It will also export the query plan that the customer was getting. So you have everything in place. You know what query plan the customer was getting, and this was obviously a bad plan. That's why you are looking at this. And then it will export these two SQL files which contain the statements to import the statistics in the test cluster. And for legacy reasons, it's also exporting the same data in JSON format. Earlier, we had a separate tool which was reading this JSON and then inserting data to the test cluster. But today, you don't need that. You can just use the SQL files to import statistics. Now, there's one more caveat here. I mentioned, so CBOstat dump, it uses PG dump to extract the DDL. And so when you're exporting the DDL for all objects in a schema, this thing works as expected, so you can get all the objects. However, when you specify a query for the CBOstat dump tool, it will try to only extract statistics for that table, or for tables that are used in that query, right? And with this, it doesn't export the create statistics commands. So it doesn't know. So yeah, it doesn't export these commands. And this is likely a bug in Postgres, which we recently found, and I think we want to upstream a fix for this to Postgres. Once again, there is a patch available for this, but you probably don't want to use it because this is on the customer's deployment, and a workaround would be to just export these commands manually, which should be fairly easy to do as well. So I'll show a demo now. Okay, so what I have here is, can you see this? Is this, or maybe I can make it a little bigger. So what I have here is instance running on, is a Postgres instance running on AWS. This is, oh, sorry, just a second. I'm just using the correct path, so it has the right binaries. Yeah, so this is a Postgres instance running on AWS. This is a C5 2x large instance, and it's running vanilla Postgres without any changes there. And what I have done here is I've loaded all the data and all the data that's from the join order benchmark. So you can see this; it contains all of these tables. And I'll show you that it has also the statistics. And what we're going to do for this demo is we have this one query. I chose a simpler query out of the join order benchmark, but just for this demonstration. But you see it has 5 join tables. And what we're going to do is try to extract the query plan and statistics for all the tables that are used in this query. And we'll see if we can use that to reproduce the issue. Right, so yeah, so this is the command we want, or maybe I'll just show you first the statistics for. So you will see that on the production environment there is actually rows in that. So in these tables, we can actually even run this query and see how it works. So I can just run it with. Yeah, so you see it took actually some time, so it actually has the data, and I'm not trying to trick you. So yeah, this has the data, and analyze has been called, so we have statistics on that. And now I want to use this command on my machine to connect to this remote host. So I'm using Python to run the script. I have provided it an IP address for the database instance. I provided username and password, the database that's called taco join order benchmark, and then a query, and then I provided it an output path. So yeah, once I run this query, you will see it's generating this output. So you see it has generated the DDL for all the tables that I used in this query. You will see 5 create table statements. It also generated also the indexes that are available in this table. So in this case, I've not overridden any GUCs, so you don't see anything here. And you see these import commands for SQL statements to import these statistics on the test cluster. So you see we import rel tuples and rel pages to the PG class table. And then we also, if there is something in the PG statistic, we remove that and we insert new rows of data that we get from the production environment. So let's try this out. I have a local instance of Postgres running with the same version. And I will create a new database here. So now this database, right, so this database is empty, doesn't have any relations right now. And what I can do is I can just, maybe I have to. Right, so I will import, so I will execute the ddl.sql file, which will basically create all the tables that I need for this query. You will see since analyze has not been called on these tables, the rel tuples for all of these tables is actually -1. Once we call analyze, you don't have to, but I'm just trying to show that these tables are empty. So you'll see now, since analyze has been called, the rel tuples is 0. And now what we want to do is import the statistics. So I will execute this SQL file again to import statistics. And now if you see these statistics, now they match the statistics that we had in the production environment, but the tables are still empty. Right? And so if we try to just execute now this query, you see it won't work. It didn't reproduce the same plan. You see the costs are close to 0. And that's because of this issue that I described before, that Postgres is looking at actual number of pages. And so for that, this is a Postgres version where I've applied the patch already. And so to make it work, you would have to enable or disable this optimization by setting this flag that I've added in the patch. So now once you've done that, then it's trusting at the rel tuples, which is available in PG class, and not looking at actual number of rel tuples. And so now when you execute this query, you will see that assigns some costs. Just a second. And I have the query plan that I was getting also from the production environment. And you see the query plan shape matches exactly, although the costs are a little bit off. So you see the costs for the entire plan is a little bit off. Now, to be frank, I'm still debugging this, and I have to still find the problem, but it looks like this is because of this optimization on Postgres, where it's looking at the actual number of pages. But yeah, so we had been using this mostly for Yugabyte, where this works precisely, so we get the exact same cost also. And we had also been using it earlier with Postgres 11, so there it was also okay. And with PG15, I've recently started testing it, and this is something we need to find a solution to. But I think it's still an effective tool because it generates still the same plan, and that can already help you a lot. So just recap what we did. If you want to reproduce the query plan, we want to check out the same version of the customer the Postgres that customer is using, apply the patches, execute the DDL, execute this gucs.sql if they have some gucs that they've overridden. Then you have to import the statistics, import extended statistics, and then enable this flag, which disables the Postgres optimization, and then run the same query with analyze, and you should be able to get the same query plan. Now, so what does this give you? Like, how does it help, right? So we've basically established a workflow for the support stuff. Like, if whenever an issue is coming from a customer, we ask them to run this, and now what this gives us is it gives us a complete package with everything that we need to debug these issues, right? It gives us the query, the version, everything. We don't have to keep asking, so it reduces the round trips. And then, of course, when an issue like this arises in production, the first thing you want to do is provide a workaround. And so this, by just reproducing this plan, you are now able to try out different hints and see if you can get a better plan. So like, of course, you will first have to look at the plan, maybe figure out, okay, this is a pain point, and I want to try to see if I can force a different join type on this and see if that could be a better plan. So, right, you try out these hints, you see the plan changes the way you expect it to, and then you provide these hints to the customer, so it reduces once more the round trips with the customers. You could also make changes to the indexes and recommend new indexes and try it out and see if the query planner is actually picking those indexes. So that is also a nice workaround for the customer. Then you can, of course, go ahead and I could actually show you in the demo, but now that we are able to reproduce it on a local machine, the test cluster can have a debug build, and you can step through that code using the debugger, so you can know exactly where the problem is. And once you know the problem and once you fix it, you are able to verify it that it will actually help the customer in that query. So you'll see if the query plan changes after your fix. And so you don't have to wait for the customer to upgrade to a new version and then realize, hey, this doesn't fix my problem. So it's a reliable way to provide solutions. And then the use case is like every time you find these issues from the customers, you could anonymize that query and you could put that in a regression test suite. So you can ensure that these issues do not reoccur, right? So because you have all of the data you need to reproduce it, you can just put it in a regression test suite and make sure that the plans don't change. Now, what else can this tool do? I mentioned already regression testing, and early on we went, so we tried to add a lot of regression tests using this tool, and we found out that in fact these tests can be very sensitive and very hard to maintain. So what happens is every time you make changes to CBO, plans may change, and now a plan has changed for a very complicated query, and you have hundreds of queries like this, and so maybe let's say plan changed for 5 queries. How do you verify this plan change is a good or bad thing? Because you don't really have the data, right? You can't execute the query and see whether this plan change is better or not. So this is something that we experienced, and we thought, okay, this should be used very judiciously. You can't just add a lot of regression tests, but in some cases it might be useful. Normally, non-blocking tests that block your releases are not a good idea. Because like tests which are very hard to maintain get out of date, and it's very messy to use this. And also, having non-blocking tests will create a lot of problems. So use this judiciously for this purpose, but it could be used for some, let's say, important customers or important problems which we don't want to reoccur. So, but then we found a solution for this, and that comes from Taco. And so what we did was we have these benchmarks in Taco, but this I described how Taco works. So Taco tries a default plan for a query, and then it tries hundreds of different plans for that query by applying different hints. So for a join order benchmark, it takes over 24 hours to run this 113 queries. And that's a very long time. So if I'm, as a developer, making some changes to cost-based optimizer, I have to wait 24 hours to find out if my change was good or bad, right? And that's not good, right? And so what we did was we exported regression tests. This is Postgres regression tests from Taco. So Taco is exporting all the DDL, the statistics, and the queries with costs off, and then it's generating this SQL file and an expected output file from Taco. And so these tests can run in minutes. And so once when I'm working on the CBO, I run these tests, and they serve as a sanity check. I can already look at the plans that have changed. I can already see if this is a good or bad plan change. And if I need to dig deeper, then I will rerun Taco, and then I will figure out if these plan changes are good or bad. So what else? It can also be used to predict impact of upgrades on query performance. So if you have a customer who is hesitant to upgrade to a new version because they don't want disruptions in their production, right? So, and one of the biggest issues with in database products is getting customers to upgrade. And that's a big challenge. And so what you can do here is you can export statistics from the older version. And since changes to this area don't happen so often, so these statistics should still be applicable in a newer version of Postgres. And you can import these statistics in a newer version and see if the query plans change in the newer version. And then if query plans do change, you can actually use the hints from that, apply it back to the old version, and see if they were actually good or bad changes. So you can very easily predict if there will be any impacts to performance from upgrades. What else? You can also use it for backup and restore of statistics. So computing statistics can also be computationally intensive. And so you can save time by backupping and restoring statistics during upgrades or migrations. Yeah. So I found a few people who complained that after auto-analyze ran, their query plans became worse. And that's the thing with CBO. It's not a perfect science. There's the paper mentions there's two wrongs can make a right. So selectivity estimation was also wrong, and cost model was also wrong. And so together they were making the right plan. And now statistics are updated, so selectivity estimates are right, and your plan gets worse. It can happen. I'm sorry for that. And so you could actually use this to restore old statistics to the version to the way they were. But now this tool is versatile, but I think I'm stretching it with this one, right? Now, coincidentally, just a couple of weeks ago, Postgres has added a functionality to restore statistics in PG18. The intended use case is actually for backup and restore of statistics, and not so much for this debugging purpose, but it can still be used in the same way. The advantage with CBO dump is it will work on legacy systems. It will work without any modifications to customer deployments. So it can still be useful for a lot of purposes. And also that this feature doesn't export extended statistics, which I think is a miss. So maybe that comes later. That is all I had. If you want to get this presentation, you can scan this QR code, but I think the presentation will also be later on the conference website. And I can take questions. Yeah.
Is there a way to know all the possible query plans that CBO has access to before it chooses the best one? By debug or any other verbose logging?
You mean all the query plans that it tried?
Yeah.
Not that I know of. But I think not, because it has to actually try a lot of plans. And as I said, it uses a dynamic programming approach. So it doesn't actually try a lot of plans for the whole query. It tries plans for subqueries.
Okay.
Yeah. Yeah.
The tool accepts the query and gets the tables and dump, right? That's wonderful. So what happens if the query is on the top of a view or something like that? Is the tool...
Right, so the way it works is, I run explain on the query with JSON on, and then I'm parsing the JSON to find all the tables in that. It's fairly simple, it's straightforward, and it works. So, but I have to say it hasn't been thoroughly tested, but yeah, it works. Any other questions? Yeah.
CPU start time for production environment. We can install it on our testing environment and connect to production Postgres.
Right, you can just use the script from anywhere. You can connect to the database. So you connect to the database, it will export all the statistics on your local machine, and then you can export it, import it to your.
Because like installing on the production machine, people may not have.
Right, exactly. So before we took this approach, we implemented the whole thing as a Postgres extension. But then installing that extension on a customer's deployment, this is more tedious. So this was just a better way to do this. Okay. Thank you so much.
Thank you.